Hi guys, I welcome you to the day 14 of the training. Today we will be going to discuss about data flow modeling, and then after we will be introducing about behavioral modeling. In the last class we have discussed about gate level modeling in the Verilog HDL. So today we will learn about data flow modeling. Some examples with data flow modeling, what is data flow modeling and how it is written, what are the advantages, and where do we use, and what are the attributes of data flow modeling, how to write the syntax, and what to be followed. Means syntax is nothing but rules. So that being said, let us go to the today's agenda. So what do we learn today? So we are going to learn about data flow modeling, operators in Verilog HDL, and introduction to behavioral modeling. Also, as I told from the last class, we are going to introduce you to the interview preparations. In the same way, we are going to discuss about interview preparation tips. So, major part that all of you are asking about how to get qualified or how to get selected in the interviews. It's not a bigger task, guys. It's about consistency and confidence. The factor confidence comes from what you learn and how many skills you possess. And also, if you possess one or two skills and if you master them, you will be achieving whatever dream job that you are aiming for. And consistency is another habit that you will be procuring day by day. It's not a single day task, it's a day by day task. So that you need to be very sure about what you are going to start learning, and then be consistent in it. Consistency is nothing but making a routine, have a regular task day by day. So you shouldn't be stopping at middle of the task. So now we are at the middle of the training, day 14. So I hope this would help in various aspects of interview preparation. It is not just making resume and sitting in the interview room and answering some set of questions and showcasing your skills. It's not about interview. It's all about how do you join in the industry. So that does really matters. So yeah, let's begin. What are we waiting? So data flow modeling. In data flow modeling, the key elements are Boolean equation, continuous assignment statements, and operators. So what are these three things? Boolean equation, we already know. Many of you are in the electronics background, I suppose. So Boolean equation is nothing but it's a functionality of the circuit in terms of equation derived from the truth tables of that circuit or the logic cells. For example, for multiplexer, you have a truth table that shows the functionality or the operation of the multiplexer. From that, we can derive an equation in between inputs and outputs. So Boolean equation is a formula or an empirical structure that is related between input and output. And continuous assignment statements is nothing but always, such that in the always module or always block, it's a procedural block. So in that block, you will be beginning the process, and then that process is beginning with an assignment statement. We also know what type of assignment that we are using. We have used in some of the previous examples. It is assign uh, word. So assign terminology. It's an assign function that we use in the entire script. We have some few examples that we are going to deliver. And operators. We'll get an introduction to the operators, which are nothing but arithmetic, logical, relational, or any other different types like comparative. Some are concatenation operators. These operators are nothing but functional elements that are used to create a functionality. For example, if you are adding two elements or two variables, two data types, so you might need some addition operator, so plus symbol. So these are the responsible functionalities or procedures that we actually implement some architecture on. So what are we writing this Verilog HDL for? Verilog HDL is written for describing or deriving the hardware design. Got it, guys? So that is a major advantage of Verilog HDL, and that's what we use Verilog HDL for in the chip design industry. For designing a chip in terms of hardware, we are designing the chip in terms of hardware using Verilog HDL. Then, but there is an important point. Important to note is that data flow modeling type of HDL development does not require storage element like reg. So it is not declared in this. Some of you might have understood from the previous lecture. If you have seen, there is a reg brackets 3.0 a. It's an array. So those type of arrays or memories, those kind of storage elements are not required, like variables, any vector. So vector reg 3.0a is a vector. So those kind of vectors or any other elements are not required in the data flow modeling. Why? Because it's purely mathematical equation. So in terms of example to the mathematical equation, you can derive a circuit or you can derive the hardware architecture. Simply between input and output, you are making this Boolean equation and deriving some functionality. So based on that functionality, your architecture is also getting connected. So let us see some operators, and then we can go with the application of data flow modeling using operators in the examples. Example 4 by 1 or 2 by 1 multiplexer. I'll show some of the examples. So here we are looking at operators. Now we have three types of operators, which are unary, binary, and ternary. Ternary is a specific operator we use at rare cases, but binary is the most used operator. In the binary operator, why do we call binary? It is about two elements or two operands. Between two attributes, we do some operation or arithmetic or any other type of relation that we set up. So between two elements, we are actually defining some operator thing. So that itself shows it is a binary operator. Unary, you can say this exclamatory mark or this dash semi dash symbol is a not. You can negotiate. Negotiate means negate we call it as. So not is used in some specific conditions we will be showcasing. If a is not equal to b, how do we write? A exclamatory mark equal to symbol and b. So in that way you can write. And we have binary operators in the types of arithmetic, logical, relational, and shift operator, concatenation operator, reduction operator. Don't get confused of these many operators. Just think, okay, for this type of specific application we will be writing or we will be using this particular symbol. So that is the operator. Then we'll look into each individual operators now. Arithmetic operators, you have add plus symbol for addition, minus for subtraction, star symbol for multiply, slash for division, and percentage for modulo. Modulo, I mean, you will be getting reminder out of percentage symbol. But yeah, we have used these symbols as of now in C language or in Verilog HTL till these examples. We have used them in specific things. In the procedural blocks, we will be using all these symbols in the Verilog HTL script. So understand where do we use these operators. These are not the outside topic. These are the essential elements of writing Verilog HTL script. In the same way, we will be having logical operators. Some of you have already seen we can represent A or B with A slash B. Usually how we write, just simple A or B, this is. And if you want A divided by B, this is what you will get. And sometimes A and B. So if A is equal to 0 and B is equal to 1, what would be the output? A and B it is 0. If 1 is 0 in AND operation, every output is 0. So this might be output, and this might be x1, and this might be x2. So these are the inputs, these are the outputs. So between inputs, operand is and equal to is derived as this can be a Boolean equation. Yeah. So Boolean equations are written in this way using operators. So and we have used this is equal to, that is again compared to relational operators. So you'll get to know in the next lesson, next slide. So not is written in this way, and XOR, OR, and XNOR. Guys, don't get confused. It is XOR, right? If you negate it, it is XNOR. So NOR and NAND also are there, that you will get to know. But these are the logical operators that if you want to use, these are the logical operators you should be using in the same way. Wherever you see them in the test bench Verilog HTL or Verilog HTL, you can identify, okay, this is XOR. Remember these. These are to be remembered, XOR and XNOR, most widely used. Now coming to the relational operators, these are the relational operators. These are equally helpful and useful at certain times, because when comparison to the two different statements, if A greater than B, I mean if A is value of 6 and B is value of 3, yes, this gives a true value, and when it is true we can define, okay, the clock should be 1, so clock should be enabled, and then the data should also follow the clock. So in this way, some relation at point A of the Verilog code, and it gives some output at point B, and the actual output at point C, the process begins where data D should be following the clock of the sequential circuit or any other logic circuit. So in that way, every operator in the logic relational operators in the Verilog HTL are useful. So don't get confused, guys. For equal to, there are two equal symbols. That means if A is equal to 6, don't get mixed up and confused with this symbol. This is 6, and if A is equal, now if I say in the Verilog HTL, if I say A is equal to B, what is the value of B now? B will be 6. And if I say case equal A equal to 3 triple equal to B, then it checks the condition between A and B, A case equal, and assign, this is most rarely used, not to get worried, and A assign B. Okay, this is just for verification. And what is this and this difference? What is the difference? So this is used in special cases in the loops, but it is most commonly used A assign B. So whatever elements in B will be assigned to the left hand side element in the element A. So that is this, and not equal to. So it is not equal to, this is how it is written. If A is not equal to B, forget this, guys. A is not equal to B, then this is a condition. So where do we use these kind of relational operators or any other operators? These are used in if conditions with some functions. So Verilog HTL, we derive functions, and also we use these relational operators in the conditions to understand whether the statement is true or false. If it is true, okay, you do some set of tasks, and if it is not true, go to the some other set of tasks. So yeah, next go to I hope you understood greater than and less than. I don't need to explain them. It is just purely comparing between bigger value and smaller value on the left hand side and right hand side. And understand, these are all binary operators. When I say uh, right shift and left shift, for example, you have a data of 1 1 0 0 1. So if you say right shift and some random example, right shift means one element can go right and the other element can be added in the left. So these will be moving towards right. So when we move towards right, this will be gone and this another element will be coming. So when you go right shift, now it is, this will be gone. So it will be gone and this will be 0 0 1 1 and some element 0 you need to add. So right shift. So left shift means this will be moving in the leftward direction. Imagine you have a array of elements. You have 4 5-bit data, 1 1 0 1 0. So if you move this to the right shift, if it is value a and you right shift the a, don't worry about syntax guys, I am explaining the functionality of the right shift. So when you click on, when you explain to the Verilog HTL and to the machine or EDA tool, you say right shift. So if you say one element right shift, so these will be shifting towards right. So the position will be varied and coming this way. So some other element will be coming here, which might be 0 in ideal cases, or if there is any other bit here in this column, attach it to this. If it is 0 or 1, 0 or 1, that will be added, that will be forwarded here. So now it is forwarded, and what is the result that you are looking for here? It is now 1 here, after 1 here it is 1. So this 0, this 1, and here 1, and here 1 1 1. So another element is left, so that is 0. So now the new value is 0 1 1 0 1. So that is the new value. Hence the left shift looks like this will be left shifted. Each element will be left shifted to the neighboring bit, and whatever the ending MSB, most significant bit, will be removed. And in the beginning position there will be adding a 0. So that is the help of right shift and left shift. So sometimes these are also used according to the sequential elements that you use in the Verilog HTL or the architecture. Just understand, you have shift operators as well. And concatenation operators are nothing but, for example, you have a wire S in the multiplexer. You have wire S. So for this, actually you have to do two selection inputs, S0 and S1, for in the 4x1 multiplexer, right? So S0 and S1, but these can be assigned in single variable S, so one wire, but S can be given with 2 bits, S1 and S0, in this way. But how do you write this? You have used concatenation to add, these are the bits. So for example 0 0 0 1 1 0 and 1 1, these are the values of S0 and S1. So now S is equal to Now S is equal to S0 comma S1. This is how you concatenate two bits, concatenate two elements, just adding them. Concatenation is nothing but adding them. So now S0 and S1. So why do I represent these as 2 bits? Then S can be declared as 2-bit binary 0 0. So as I said, size and radix and value. This is how you represent a number value. S is now 0 0. So 0 0 means 1 0 will be 0 and that will. And now if it is 2-bit binary 0 1 or 2-bit binary 1 0 or 2-bit binary 1 1. So now S0 is equal to 1, S1 is equal to 1. Now S0 is equal to 1, S1 is equal to 0. S0 is equal to 0, S1 is equal to 1. So this is S0 and this is S1. So you can say S can be assigned as a single wire. So you need to declare wire S. In the Verilog HTML, how do you write? Assign S is equal to concatenation S0 and S1. Why? Because you are simply declaring one wire with 2 bits in it. It's a 2-bit wire, but you need to mention what is the size, right? So for that you need to add how will you write for 2-bit size 1 0 S. This is how you declare wire, semicolon. Okay, so you declare in this way and then assign values of 0. What are you assigning? 0 and 0 or 0 1 1 0 or 1 1 binary bits, 2 binary bits. So that is how you represent. I hope you understood here. And other elements like reduction operators are and element, or element, not element, or XOR element in this way. Yeah, so now we understood the operators. Let us go to the data flow modeling. So that is, we have an example for 1-bit adder and also for 4-bit adder. For 1-bit adder, it is how you write this module, and for 4-bit adder, this is how you write the module code, Verilog HTML code for 4-bit adder. So simple, you know the equation. This is how you assign the values using assign function. Simple. In the data flow modeling, you can use assign and directly write output and relation between inputs with the operators, arithmetic or logical or relational operators. So let us go through each code. So 1-bit adder, module 1. How do you write Verilog HTML? I'll come from the beginning. So you write Verilog HTML from this way. Just you need to mention this is part 1. Okay, so this is part 2. What are these parts? I'll explain. And this is part 3. Remember guys, this is again in the data flow modeling. So this is part 4. Got it? Now part 1 is nothing but declaring the module name with inputs and outputs. So these are the inputs and output. I'll mention output, and this is the name of the 1-bit adder. I have mentioned in this way. You can also write as 1_bit_adder. Why I mention underscore here? It is for ease of understanding. If you give a space, right, machine can't understand. Or you can simply write without underscores, you can write 1-bit adder in a single word. It should be case sensitive. So case sensitive is nothing but either it is an alphanumeric or lowercase. Write it in a lowercase representation at all the times and remember that name. So I have written add 1 as without space, then input and outputs. Now with this you can also say the second part as input and output declarations. Usually in the third part you declare wires and registers, but not necessary here in the data flow modeling. You are not declaring wires and all these things because we don't need storage elements. So you can mention wires. You will be mentioning wires. I'll give you some examples as well, but this is a vector addition. Vector addition is nothing but as you write mathematical equation c is equal to a plus b. In that way, write a function called assign, which is a predefined function. You haven't discovered it. It is a predefined function assign that you need to mention. Assign means whatever value you get in the a plus b, after operation it should be stored in the c. Understood, guys? I'll explain in this as well. Then the fourth part is end module. You begin the module here, you end the module here. And don't get confused with always or other things like initial, begin. Those are the procedural blocks that we can see in the behavioral modeling, but don't get confused between gate level modeling, data flow modeling, or behavioral modeling. I have explained a clean difference between all these three in the day 12 or day 11 of the training. Just watch it again before I end the availability. I'll be closing the availability very soon, and then after this 1-bit adder, check for the 4-bit adder. In the 4-bit adder, the same thing. This is the first part and this is the second part, this is the third part and fourth part. So first part, always you mention module name and input and output, same everywhere, same. And second one, declare input and outputs. Why are we mentioning 4-bit? If you haven't mentioned anything, by default Verilog HDL code will be understood as 1-bit by the EDA tools, by the machines. But if you want to mention, okay, this is a 4-bit addition, you need to declare, okay, all the inputs. For example, you have an adder here, let us say, and you have 2 inputs here and 1 output. This is what we are looking at, right? So for this block, you have A, you have B, and you have also C. For these, why I have mentioned wires, I mean input as 3.0. As I am repeating again, all inputs are wires, all outputs are registers, but not in the data flow modeling. We are mentioning only inputs and outputs in the data flow modeling for this particular 4-bit adder. If it is 8-bit adder, okay, all the inputs are 8 bits, but output should be 1 bit extra. For example, 0, 0, 1, 2, 3, 4. How many bits you have? 5 bits. Why did I take output as 5 bits? Why didn't I take output as 4 bits? Because if there is a carry after you add, output shouldn't be losing the data. For example, if it is 6 and 3, you have only 9 as output, correct? But if you have 6 plus 9, where is this going? It is going to 2 digit. In the same way, if we add elements and if we get some additional carry at the output, So that carry should be stored in the last MSB, last bit. So in that way I have added all these things. So for example, 4 bit and 4 bit adds on up to let us say A is 4 bit 1110, and B is another 4 bit 1111. So definitely you can see by this one additions we will get one carry. For example, 0 and 1 1 1 0 0 and carry, and here 1 plus 1 I will write carry here. This is carry, it is not 1 adding. So 1 plus 1 0 and carry 1, but 0 plus 1 here 1, and what is here this value called 1 plus 1 0, and 0 and 1 carry. So 1 plus this is also 1, and there is one another thing, so it should be written here. So this is the carry for these two elements, and this is the carry for these two elements, and this one is carry for these two ones. So you might get confused with all these things, but don't get confused. After adding 1 1 you will get output as 0 and sum as 0 and carry as 1. That's what we do binary additions. That is how we do. So this is the output we get, 1110. And where do we store this? If we have only 4 bit of output, 4 bit wire, for example it is 4 bit, and you can store only 4 bits of wire, 4 bits of data. No, data shouldn't be in the horizontal way, actually it is in the vertical direction, 1 2 3 4. But if this is a 5 bit thing, this one will be stored in the sorry guys, I'll share it in the other color. Yeah, if this is 1, and this one can be stored in last size bit, I mean additional bit carry. So so other things it is storing is 1 1 0 1. That is what it is storing. Understood guys? I hope you all understood it. So yeah, I hope I have explained everything well. If you are still confused, you can see this is binary, I mean decimal 14, this is 15, and what do you add? If you add, your answer should be 29, and if you see the value of the output, this is again 2 power 0, 2 power 1, 2 power 2, and 2 power 3, and 2 power 4. So the value is 16 plus 8 plus 4 plus 1. So it is 24, 28 equal to 29. So that is what the value of 14 plus 15 is. So 29. This is how the data is stored. So then now what is the value of C here? It is 29 in decimal, but in binary it is 111001. So it is a 5 bit output. It's a 5 bit output. And what is the input we have given? A as 14, that is 110, and B is 111 and 1. So it is 15 again, it is 14 again. So in this way we are making machine to understand the Verilog HDL structure of a 4 bit adder. Why it is 4 bit adder? We are adding 4 bits. That is the reason we have mentioned 4 bits for the inputs. Got it guys? So I hope I can restore it. No, I can't restore it. So that is a simple explanation. Please do watch again if you want. Yeah, so then coming to the XOR operator and AND operator. Now we have seen AND I mean plus operator, we can see XOR and operator with the same specifications. This is first part, you will be declaring module name, module and all, and input and outputs, XOR operator I have just simply mentioned, and here it should be AND operator and XOR operator. So here I should write as AND, actually I did a mistake. So AND operator, then between input and output what are we doing? AND. So and we are also mentioning the what type of output size we should be declaring. It is better to declare in that way. So because logic operations are bitwise operators, remember this point guys. That is the reason we should be mentioning this type of size for input and output. Then after assign the values. This is the XOR operator and this is the AND operator. Remember this. And remember this. So AND module, that's it. So it's simple in writing data flow modeling, but you need to understand the Boolean equation or the continuity. So let us go to the next topic, that is full adder implementation using logical operators. So you already know with the full adder we can see a Boolean equation called A XOR B XOR C in. I have explained this full adder implementation using gate level modeling as well, and now I am explaining this full adder implementation in the data flow modeling. So carry A dot B plus B dot C in plus A dot C in. So this is what carry will be assigned in the full adder application. So for the full adder implementation, these are the two Boolean equations you should be working on. This is the functionality of full adder. In the same way, for any counter, for any multiplexer, you will see the functionality. So for those, module full adder example, this is the first part and this is the second part, and third part assign them something, and fourth and it. So how do we assign? For each logical equation or Boolean equation, we assign values for the output in terms of input. So module full adder, it is no space in here. You can add underscore full underscore adder. Don't make any syntax errors like this giving spaces, and add a comma b comma c in sum and carry. These are all the inputs and these are the outputs. The outputs are assigned in this way. Output is equal to some operation between inputs. That is what we are looking here. So in terms of A XOR B, just imagine A XOR B, how it is written. So if you have A and if you have B, how these are written? XOR is symbol in this way. Okay, A XOR B is in this way. So now C in B XOR C in, right? Carry in. How do we write? I will declare with another color. So now A XOR B, the output is A XOR B. This output is again added with C in. So now the output is A XOR B XOR C in. So the functionality is taken from the left to right. So in this way we get the sum. This is now output is sum. Sum is equal to A XOR B XOR C in. Got it guys? In the same way, carry is nothing but A and B. So whatever we have A and B values, those to be and operand. And B dot C in again. So dot, it is another AND gate. cin. So yeah, a dot cin, again derive one element, and this is another AND gate for this. So if we add all these three elements with OR gate, that is carry. So in this way you can do. That is how logic circuit will be applied. From this Verilog HDL code, your logic gate or logic circuit will be implemented. So we need Boolean equations like this. Sum and carry. Remember these guys, for full adder, sum and carry will be in this way. Okay. So at the end, data flow modeling, we are going with ternary operator with the question mark and dot. How it is operated now? Question mark and colon, I will explain with a simple example. So for example, in the multiplexer you have S, and you have two inputs A and B. To select which input, what is the advantage of ternary operator? It's nothing but it's a ease of application. That is why we are making it. So in the output and between inputs, y is equal to S colon S question mark B colon A. How it is chosen? So if S is equal to 1, second input B is chosen, and whatever data you have, for example don't care, some don't care, or 1 or 0 is there, it is taken into Y. And if S is equal to 0, the primary first input will be followed to the Y output. So that is what the equation is. Whatever you write, you need to assign this value as assign Y is equal to S question mark B colon A. So you will be seeing in the practical example here in the code. So see, let us consider 2x1 multiplexer implementation. That's what I have explained in the ternary before slide. Remember this, how it is represented. If S is equal to 0, A, you don't need to write this part. This is for your understanding and explanation. Ternary operators are also used in the very complex programming, but these are very helpful in writing very complicated equations into easier one. It is a ease of representation. So then come to the 2x1 multiplexer, and in the 2x1 multiplexer you can mention module name. It is A, B, S and Y. What are the inputs? A, B and S. S is a selection input and output is Y. Why didn't I mention what type of bits? Because in the multiplexer, in the 2x1 multiplexer, each input is 1 bit carry. 1 bit carry. Either 1 bit. 1 or 0. Either 1 or 0. Only 1 bit is carried. No, not both at the same time. So it is a single bit. So output is Y. Then assign. This is how you need to write the syntax. Assign output is equal to assign output. Read along with me. Output is equal to input. What type of input? Choose selection. But how do you choose selection? The question mark. I'm explaining question mark. How do you choose selection? If S is equal to 1, go here. If S is equal to 0, go for A. So that is how you end the module. Understood, guys? So that is how represented. And if it is in 4x1 multiplexer, this is how you will be writing. So yeah, if S1 is equal to 1, you have two inputs for the 4x1, right? S0 and S1 selection points. How many number of inputs? 4. So it is 2 power 2 So two selection inputs. If you can understand and recall the basics of multiplexer, you can see if there are 4 inputs, then 2 power n and n number of selection inputs. So if there are 2 power n of inputs, right, there are n number of selection inputs. So selections are also inputs, and these inputs are major inputs. For that, you need to mention if S1 is equal, based on S1 you need to decide what is S0. So follow along with me with the red and blue lines. That is why I'm explaining individually between the data flow modeling, behavioral modeling and gate level modeling. It is not the time, it's not the time, it's about the understanding. So go to the S1. If S1 is equal to 1, come to this bracket. See, again, the empirical syntax is same for ternary operator. One input, question mark, and then choosing of which input to be selected. Okay, I choose S0 if S1 is equal to 1, and in this again ternary operator, S0 is equal to C. I choose C if S0 is equal to 0. Let us consider one by one. If for suppose S0 and S1 is equal to 0 and 0. Starting point. Let us come to S0 is equal to 0 and S1 is equal to 0. So I will choose S1 is equal to 0. So what I should do? I should go to this selection input. Remember guys, always 0th selection or 0th data bit that you are choosing for the selection will be taken to the next bit. I mean in the second position of the syntax. In the S0, now come to the S0. Internally S0 should also decide. What is S0? So S0 is equal to 0. Here S0 is equal to 0, right? Now we have 0 and 0. What is chosen? A is selected. That is how multiplexer works. Now if you can understand, if it is a multiplexer, you have two selection inputs, S0 and S1. It is A, it is B, it is C and D. I'll write B, C and D. When are these selected? Don't get confused guys, I am not giving any input 0 1 0 1 or 1 0 1 0 or something. No, I am giving input, selection input. If S0 and S1 is 0 0, select A, 0 1 B, 1 0 C and 1 1 D. So output is equal to, output is based on the selection input. If it is now 0 0, A is selected. So I'll change. Now if it is S0 and S1 are 0 0, then A is selected and whatever the data is there, A is sent to output Y. So it is 0. Or if it is 1, you get 0 or 1. Whatever the data is sitting in A, it goes to the Y because selections are 0 0. And by this thing you can also try for what if S0 and S1 are 1 0. Try it out on yourself and then come back to me if you don't understand this ternary operator in this way. So this is how the syntax is written. Question mark and then one output, second output and first output, semicolon. So which one do you choose? If it is 0, you choose this, and if it is 1, you choose this. So that is how it works. So By this, I hope you understood what is data flow modeling. I don't want to brag on this behavioral modeling. I will give you some interview tips and then I'll close here. This will be explained in the next lecture tomorrow. So, interview tips. So, what are the key elements of interview? I will be taking class individually for interview preparations as well. One class will be dedicated for interview tips in this entire training, one or two classes. In that, I'll cover most of the things, but every day I'll try to inculcate few topics like personality, attitude, mindset, required assets for interview. Like, what are the required things? You should be prepared for what type of company that you are going to sit for a placement, or what are the offline campus job roles that you are applying for, and then resume, cover letter, how to set up a LinkedIn, how to write a cover letter using some tools here and there, and using some sample cover letters. Understand the cover letters first, and then presentation. You can also look at how do you present yourself in the interview rooms, and how do you present your resume to them. So again, all these things, the way of communicating and the way of contact, all these matters. And the other things are sources for interview preparations. For example, if you are preparing for a specific job role, where can you search for this thing? If you are applying for programming jobs, or if you are applying for any hardware related jobs, where do you find the material to get prepared for? And I will also show some genuine sources and how to search for jobs. Okay, this is the key point I will discuss in one of the training classes. And communication skills, this is key important role. Many of you are lagging at communication skills, I suppose, but I'm not insisting all of you are in that position. But communication skills is the key role to express your deliverables in the projects, or in the skills, or in the knowledge that you process. So next thing, projects and portfolio building. As we are getting trained in this Verilog HTL and FPGA training, you might have done some very unique tasks in developing these projects and all. So you can add those projects into your portfolio by saying that we have understood so and so from this entire training in the projects. And interview skills, this is must required. This talks about everything that is there in the interview skills, and I will share my earlier age interview experiences that I have faced across globe. I mean, I have faced interviews with major tech companies in global wide. So I knew few benefit uh, few benefited things, like out of my experiences in the industry and all. I want to share these tips. So personality, I think that I can continue tomorrow as well. But for the personality, everything starts from you inside. So you should be healthy and focusing on what to have in diet, or what to be done in specific tasks. So focus on every single task, one task at a time, guys. So I'll talk more about these interview tips, like these interview tips, in the upcoming classes. So here ends the today's training. Thank you one and all. If you have any questions, you can ask me in the WhatsApp chat, or you can talk to me directly in the WhatsApp chat. I am available. If I am not replying soon, I will definitely reply to each and every query. Thank you for attending day 14, and happy learning. Thank you.